Hey all you cool cats. Today I'm going to go over some good practices of how you can use long division, and I'm going to model it with both partial products and the standard algorithm. I know that some of you are using one or the other. Again, keep practicing with the one that you're most comfortable with. Don't switch back and forth. It's causing you to be confused. So when you have a two-digit divisor, the suggestion I have for you is to list out the multiples to help you for both of the strategies. So let's list out the multiples of 31. So 31 times 1 is 31. 31 times 2 would be 62. 31 times 3 would be 93. 31 times 4 would be 124. 31 times 5 would be 155. 31 times 6 would be 186. I'm going to go to times 7 just to be safe. I usually go to just times 5, but this one's a little bit challenging because I can't think of numbers that go into 812 that are multiples of 31. So it's plus 77, 8, 9, 10, 11, 217. So 31, so that's 186 and 217. 186 and 217. So I listed out all my multiples of 31. Remember last year we called it the secret cheat sheet. So let's talk about partial quotients first. So with partial quotients, we extend our multiplication house down. And the idea is that we are going to start multiplying 31 by numbers, other factors, and reducing this dividend as much as possible till we get to a number that is 0 or less than 31. And we're going to record the numbers we multiply over here. We're all going to have different answers based upon which factors we use. But if you think of a really solid factor to get you started, it kind of falls together nicely. So if I think about this, which one of these numbers as extended facts would help me get closer to 812. So if these were 31 times 10, 31 times 20, 31 times 30, 31 times 40, 31 times 50, 31 times 60, 31 times 70, what would they be? So look, if I look at that, 31 times 10 would be 310, right? 31 times 20 would be 620. 31 times 30 would be 930. I'm already over with 930. So let's go with 31 times 20. So I go 31, you can even do this if you need to, times 20. So 31 times 20, and you're going to record your spot answer right there. 31 times 20 is 620. Now we subtract. So the steps are first looking at your multiples, second multiplying, then subtracting. So we'll say multiples, multiply, subtract. 2 minus 0 is 2. 11, need to regroup here, minus 2 is 9. 7 minus 6 is 1. So now we have 192. 192 is left over. Make sure I did my math correctly. 10 to precision. So now we repeat. We looked at multiples, we multiplied, we subtracted, now we're repeating. So my repetition would be looking at the multiples again. Which one of these would get me closest to 192? I don't think I can use any of my powers of 10 here. because they're all over 192. Let's go with the actual multiples of 31 that are less than 10, those factors that are less than 10. So what I mean by that is 31 times 1 times 2, 31 times 3, 31 times 4, instead of 31 times 10, 31 times 20, 31 times 30, 31 times 40. So we have 31, 62, 93, 124, 155, 186, 217. 186, it's like The Price is Right, is the closest without going over. 186 is the closest without going over. And that multiple of 31 is times 6. So 31 times 6 equals 186. It's the closest to 192 without going over. I'll say that one more time because I think this is where we have trouble. 31 times 6 equals 186. This is a multiple of my divisor. And the product of that 186 is closest to my 192 without going over. So I'm going to write my times 6, my 186, do my subtraction. I need to regroup again. So this would become an 8. We're taking 10s from here. So 10 ones plus 2 is 12. 12 minus 6 is 6. 8 minus 8 is 0. 1 minus 1 is 0. So we have 6 left over. 31 cannot go into 6. It's larger, so that becomes my remainder. We go over into this column and we add up our partial quotients. 20 plus 6 is 26. Remainder 6. So the next way I want to show you this would be through the traditional algorithm. I am a bigger fan of partial products because the traditional algorithm, if you don't know your multiples, you'll get stuck. So again, this multiple list for both of these strategies is pretty crucial. I would say that this is something that you absolutely should consider doing, at least to the 5th multiple to help you. So let's look at the traditional algorithm. Our problem was 812 divided by 31. Go to pink. And I have to, I'm going to make it a little bit bigger. So you can see. So our steps in the traditional algorithm follow that mnemonic I gave you. Does McDonald's sell burgers? Really? Use that inflection when you remember that. Divide, multiply, subtract, bring down, repeat, or remainder. Repeat or remainder is that step. So when we are looking at the traditional algorithm, we don't go right to left. We're looking at left to right and the numbers that way. So the first step you're going to look at is the first place value on the left, which is in the hundreds. 31 cannot go into 8. It's too big. So now let's look at both place values, 81. 31 can go into 81. So this is where you do your division. 31 goes into 81, if you look at my multiple list, only 2 times, because if we did 3 times, we would go over. So 31 times 2 is 62. So the next step is to multiply. We know 31 can only go into 81 2 times. That 2 goes right over that place value that we're the last one we're looking at. So the 1 here and the 81. I know you want to say that that's 800 and that's 10. And I know that's kind of counterintuitive to everything we've done in math, but that's what always tripped me up with long division, is we're just moving our way over the number. So 31 goes into 81 2 times, and that's 62. So next step is multiplication. So 31 times 2 is 62. Now we're looking at subtract. We're subtracting the 62 from the 81. You're not even thinking about this 2 right now. Again, I need to do my regrouping. So this is a 7, this is an 11, because you're taking 10 ones and adding it to that. So that's 10 ones plus 1 1 is 11. 11 minus 2 is 9. 7 minus 6 is 1. So the next step here, after we've subtracted, is B, bring down. We're going to bring down that 2. Now, we're looking at repeat or remainder. Well, this number here is larger than my divisor, so we are definitely going to repeat. So go back to division. Looking at my place value, you can't divide 31 by 1. You can't divide it by 19. You have to divide it all by the whole 192. I don't know about you, but I don't know my 31 factors very well. So that's why I draw from this multiple list to get me closest to 192. If you look down the list, times 1 is 31. 31 times 2 is 62. 31 times 3 is 93. 31 times 4 is 124. 31 times 5 is 155. 31 times 6 is 186. That is pretty close to that. 31 times 7 is 217. Like The Price is Right, we've gone over. So it's the closest without going over. So we're going to say times 6. So 31 times 6, that goes over the last place value you're working at, equals 186. And then we do our next step, subtract. We have to do some regrouping. So we're taking a 10 from the tens place. That should be an 8. Can you see that 8 there? Just made my marker funky. Adding 10 to that 2 makes it a 12. 12 minus 6 is 6. 8 minus 8 is 0. 1 minus 1 is 0. We have 6. So our final quotient, just like in the last one, is 26, remainder 6. 26, remainder 6. So the biggest takeaway I want from this review video for you is this. Make this list of multiples. I'm speaking directly to you, Mr. Smith, Mr. Rowley, Mr. Lewis, if you are still with us, Mr. Jonesbury, all of you guys. The list of multiples is going to help you with this part right here. The problem I think we're having is that we're all trying to think of those multiples on the fly, and we're getting confused because in our mind we're trying to do the math for the multiples while doing the math for the long division, which is a multi-step process. So I am not going to help you do this until you do this first, at least to the 5 steps. And that will help me help you with that. Capiche? Alright, you cool cats. I say that, and I want to tell you that I'm very proud of all the hard work you've done in math this year. It's been amazing that we're really, really diving deep. So, I will see you soon. Good luck.